Okay, here's our review video for week 12. Before you start, I just want to let you know some things. First of all, on this review, there is not a ton of practice about graphing or domain and range. We spent a good amount of time in class doing that, so do make sure that you look over those assignments, that you know how to graph from an equation and how to state the domain and range from an equation, and I guess from a graph also. So make sure that you know how to do that. And then also, I just wanted to make sure that before you're watching this video that you have attempted as much of this packet as you can. And by that, I mean you really should probably have all but maybe 2 or 3 questions answered that you're stuck on. If you're stuck on more than that, just be aware you need to be pausing the video as soon as you think you can try a problem instead of watching me do the entire thing. Otherwise, I don't think you're setting yourself up to be as successful as possible on your test for Friday. So let's go ahead and dig into this first section. All right, so the first section is saying to find the common ratio. You all know that geometric, common ratio, all those terms go together. That's not what I meant to do. So we want to find how is this changing by multiplication or division, and then what will the next 3 terms be. So if you map this first one out, you should be seeing that we're multiplying by -4. So we're just going to continue that pattern to get the next 3 terms. And I'm going to be honest with you, I do not have a calculator at the moment, and I am being too lazy to use my phone calculator. So just know that since you're multiplying by -4, you need to continue that pattern. If you've done that and you're just trying to check your answer, one thing to check for, the next term and then the third to next term should both be negative since you're multiplying by negative values, so you can check that that part's correct. Question 2, I do notice on this question that I've got some fractions being introduced. So this first one is 3/1. So to me that looks like the bottom number is maybe being multiplied by a 2. But the top number is just changing sign. So I'm going to say here that this difference is -1/2, or the ratio rather. This is multiplying by -1/2 each time. You can use a calculator to figure that out by dividing 2 successive terms or 2 terms that are back to back. So if I continue this one, this I can do without a calculator. I'm going to get -3/16, +3/32, and -3/64. All right, questions 3 and 4 say state if the sequence is geometric. You all know that geometric, exponential, patterns of multiplication and division all mean the same thing. So this first one is going to be no. This is subtracting 2 every time I'm looking for a pattern of multiplication or division. Question 4 is going to be a yes. In fact, we are multiplying here by -2 every time. All right, 2 different versions of the formula for the sequence below. So what I mean by that is just write the same, obviously the same type of formula. I'm just saying 2 different versions using different values. So for example, question 5, I see that the common difference here is times 2. So I could write y, make that look like a y equals 2.5. With parentheses 2x minus 1, and remember I'm doing that because this is the first term, and maybe another way to write that would be 5 times 2 to the x minus 2, because 5 is the second term. All right, similarly for question 6, there are an infinite number of ways that you could write this, but I'll start with just the first one, y equals 2. On this one, we're dividing by 2, so that means my common ratio is 1/2. And then 2 is my first term, so my exponent will be x minus 1. If you had gone backwards to use the 0 term out here, then you could have used the exponent just x. All right, find the term named in the problem. Now, there are 2 ways to do these problems, and I will say this a few times throughout this video. You can just continue the pattern until you get to the requested term, be it the 12th, 9th, whatever it asks for. I think it's going to be easier for us to write an equation and then either use your calculator or plug in somehow to find the value. So what I mean by that is I see that this first question 7, I'm multiplying by 3 and I'm starting at 1. So one of the ways to write this equation is y equals, or you all can write f of x equals, that part's irrelevant. So let's see, y equals 1 and then 3 to the x minus 1, because 1 is the first term. So if I want to find the 12th term, I can do y equals 1 times 3 to the 12 minus 1. Or you can use this equation in a table and find the 12th term. And by in a table, I mean in a table in your calculator. Either way, you should be getting the same value. And again, I told you I don't have a calculator, so I'm not going to work that part out. But you should have that worked out and can check that on your own. And then similarly for question 8, just set up the same equation. It looks like question 8 is multiplying by 5 again, except I'm just starting at -1 this time. So y equals -1 times 5 to the x minus 1 power. And then just same idea. You can plug 9 in here, or you can type this equation in and look for 9 in your table. Whatever you decide to do, just know you need to be good at that so that you can stick with that method for your test tomorrow. All right, and then the last questions, 9 and 10, which formula is correct for the sequence? So 10 is actually an exact replica of question 8, which we already kind of did. And it looks like, now this may be a little hard for you to make sense of. You can probably tell that A is definitely wrong because 25 is not the first term. Again, for C, 5 is not the first term. What's weird about B and D is it doesn't look like they have a beginning number, but really B is the same as -1 times 5 to the n minus 1. So really B is your answer there. D would be the same as saying 1 times 5 to the n minus 1. Okay, so if you think about that and we look at question 9 here then, question 9, it looks like we're multiplying by -4, and my first term is at 1. So I can pretty easily cancel out A, because A says we start at -2 and multiply by 2. That's not true. D says we start at -2 and multiply by 4. That's not true. So on C, we're multiplying by -4, and there's like a 1 that's out here in the front. That's the one that I want. This B is saying -1 times 4 to the n minus 1, which would mean we're starting at -1 and multiplying by +4, which is not true for this case. Okay, now we haven't talked really about recursive formulas in quite some time. We have not talked about them this week. However, these questions, if there is a question like this in your test tomorrow, it will be multiple choice. And so I just want to talk to you about how to do kind of some process of elimination. So you know that this A1 here is going to mean the first term. So first I'm just going to go through and eliminate. It says the first term is -64. So I can pretty clearly see that option A and B don't make any sense. I need A1 to be -64, which is correct in options C and D. And then even if you don't understand the notation for the rest of this problem, I can see that on C it's saying to multiply by -1/3, and on D it's saying to multiply by 1/2. So if I look at the sequence that they give me, the question is, am I dividing by -3, which is the same as multiplying by -1/3, or am I dividing by 2? And it looks like I'm dividing by 2 here, so my correct answer is going to be D. If I use that same kind of process of elimination on 12, think about what the first answer you should cross out will be. And it should be that you've crossed out C because A1 is not 1.2. And then I just want to think about the pattern. So it looks like, sometimes it's hard to tell from decimals, but if you pick easier parts in the pattern, this is definitely multiplying by -5. And so B is the only one that is saying that. A is saying you're going to multiply by -1/3, and D is reading that you need to multiply by -1/5. So just make sure you understand how to do those by process of elimination. All right. Question 13 is saying find a term in the geometric sequence, find the eighth term. So again, you could count up. So like one thing you could do is you could create a table here and put the second term is 8, which is what this A2 equals 8 means. And then R is -2. We could just multiply by -2 until we get all the way up to the eighth term. We could keep that going, which you are totally welcome to do. Some of you are actually going to prefer to do that. I personally think it's easier to write a formula. So if it were me, I would be writing y equals 8 times -2 to the x minus 2. Remember, you have to change this exponent to match what point you're using to start with. And then since that's the case, if I want to find the eighth term, you're just going to plug 8 into the x value. Not the entire exponent, but just the x value. Or you could use a table in your calculator and look for 8, assuming that you type in this exact equation. And then for this one, I am getting 512. I did whip out the calculator for you all. And then on question 14, again, you could make a table. You could say the sixth value is negative 6,250, and then we could just multiply by 5 until we got to term 8. That would actually probably be just a quicker method here. So I would just multiply by 5. And if you do that twice in the end, I'm getting 156,250 when I'm trying to get to the eighth term there. So either way, you can write an equation or just make a table. It makes no difference to me. It's as long as you can figure that out. All right, and then question 15, they're going to give me 2 random terms and ask me to write the formula. So you did have a few problems like this on that 15.2 worksheet that you did. So this is A1 is 2, so that means the first term is 2. So I'm writing that weird. All right, the first term is 2. This is the first one. And then I need to find the fourth term, first, second, third. The fourth term is -250. So we're trying to figure out what's it changing by here. And again, this is kind of like process of elimination. What I try to tell some of you is you can just keep multiplying 2 by a few different things until you get to where you're going. For instance, like you could try 2 times 3. Well, if you try multiplying by 3, that's going to give you 6 and then 18. And 3 times 18 is definitely not -250. So you know 3 doesn't work. You could just count up that way. So you're really just trying to find some numbers until you can get to -250. And it should be that when you multiply this, make sure you pause the video and try this on your own if you haven't done this already. But I'm pretty sure that if we multiply this, I think I'm looking at -5 is my guess. So it's going to give me -10 and +50. And then +50 times -5 is -250. So I figured out what I'm multiplying by. So now I can go ahead and write my formula, which is going to be y equals 2 -5 to the x minus 1. All right, so here's part 2 of your review. We're going to solve these first problems. So remember, they're giving me the information that I need. We did these first few problems using tables, whether you do them by hand or in a calculator, either way. So we're going to say my starting point is at 2, and then the pattern saying to multiply by 3, and I'm looking for when will I get to 162. So you're just going to keep this table going, 2, 6, 18, 54, and then if I multiply that by 3, that is going to give me 162, making that the first, second, third, fourth term. So the correct answer here is going to be x equals 4. All right, question 2, similarly, I know some of you aren't a fan of the fractions, but my 0 term is going to be 4. And then the 1/2, that means I need to be multiplying by a half. So if I multiply by a half going forward, now if you're going to do this by hand, because this is good for you to know, 4 over 1 times 1/2, that's how you multiply fractions. That gives you 4 over 2, which is the same thing as just 2. And then if I keep going and multiply by half again, half of 2 is 1, half of 1 is 1/2. That gives me the answer 1, 2, 3. So I met my target number at the third term, so that's going to mean x equals 3. Question 3 and 4 are both word problems, so just remember some of your key words. This is decreasing. Also with percents, we need to move the decimal 2 different places, so I'm going to do y equals 23,000 times 1 minus 0.08 to the x. And then you'll just use your calculator to be able to find when will the car reach 10,000. And so we're going to be looking at that in the table part of your calculator. Ignore this to the nearest tenth part. We haven't talked about that yet. Okay, question 4, again, start by writing the equation. So y equals, they give me a starting value of 6,500. It's increasing at a rate of 4% per year, so that's 1 plus 0.04. And when will the town's population be in 4 years? So I'm going to put an x there, and then you'll either plug 4 into this x value, or you're going to use the table function in your calculator. Whatever you need to do to be able to find that population. Question 5 and 6 is going to go with it. Which equation best fits the data shown? This is very, very similar to the questions from the beginning. So I know, let's see, it looks like we're multiplying by 2 every time. So I'm going to be looking with something with like 2 to the x, which is going to cancel out options C and B here. And then my first or 0 term, since I'm using an x exponent, is 3, which is going to make D my answer. A would mean that the first term or the 0 term is 1.3, and we know that's not true. So your explanation for question 6 is just explaining how you knew that D was correct. The 0 term is 3, and the common ratio is 2. Okay, we're getting close. So this is saying which of these are exponential or show exponential. So remember, the top one, the x's are just telling me the term number, so I'm really just focusing on the y parts of all of these. That's the only part that I really care to look at. And I'm trying to determine which one of these are exponential, which means a pattern of multiplication or division. Well, I can see in this first table, I am not multiplying or dividing by anything really. It's kind of jumping back and forth. And remember, none of these ever hit 0, so that definitely doesn't make any sense. So here I'm going to say no, this is not exponential. Part B, it looks like I am dividing by the same thing every time. Looks like I'm dividing by 3, so yes, this is exponential. The third one down here, let's see, it does not appear that I'm dividing by the same thing every time. I personally see a pattern there, but not a pattern of multiplication or division, so again, that will be a no. And my last one, 16, 8, 4, and 2, that appears to be dividing by 2 every time, so I'll say yes. Okay, question 8, really very, very similar. It's written in a slightly different format. So again, like the tables, we only care about these y values. This is saying which ones make linear. So exponential is when you have multiplication or division. Linear should make you think about arithmetic. This is all spelled wrong, but should make you think about arithmetic, which is addition or subtraction. So we're looking which ones of these are patterns of addition and subtraction on the y x values, because the x values aren't telling you anything about the sequence. So like for A, for example, 4, 9, 16, and 25, that is not adding the same thing every time, so that's going to be a no. That's a weird way for me to mark that, no. B, it It looks like this is plus 1, oh, minus 1, so that's also a no. C, this is minus 6, minus 6, minus 6, that's a yes. That is subtracting the same thing every time. And then the last one, that's plus 0.2, plus 0.2, plus 0.2 between these y values right here. So that is going to be a yes as well. All right, this last page. On question 9, it says make a table of values. Now, you don't have to necessarily make that table by hand, but what I would like to do is, even if you use your calculator, I would like to see the table that you're actually making. So remember, this means that you're going to start at 1/4. Moving forward is always, or to the right rather, is always multiplication. So like, for instance, the next term will be 3/4, and you can use a calculator. And then moving to the left is going to be division. So we're going to divide that by 3 and get 1/12, or you might have a decimal in that place. So I need to see a complete table there to match the graph space that they've given you. All right, so whatever you've done to get your points, this specific example is not the easiest when it comes to graphing, but I know that I picked maybe some better ones for your test. So we're going to start at 1/4, which is right here between 0.5 and 0. Our 1 value is going to be at 3/4, which is going to be right here. And our 2 value is going to be up at 9/4, which is a little bit past 2. And then going the other direction, I've got 1 at 1/12, which is really close to 0, and still closer to 0, but not hitting it. This would be a good time for you to practice domain and range. Just remember, domain is always all real numbers. Range is y is, this one is going to be greater because where everything's above the x-axis, 0. Remember that this can never be greater than or equal to, because asymptotes, you can't actually touch that line. All right, so it should be already marked this way on yours. I just don't have it on mine. You're going to skip questions 10 and 11. All right, question 12. This one says, it's another word problem, so the first thing that we're going to want to do is write an equation, and then we'll be able to solve the problem. So it says, we're starting with an area of 2,000, so it's going to be y equals 2,000. We are decreasing this time, so we're going to do 1 minus, still move the decimal place, 0.15, so we're going to move it 2 times, and then to the x power. And you can, again, you can either plug in 5 right there for x, or type it into a table to look for the appropriate matching value. Question 13 says, state the starting point, increasing or decreasing the percentage. And this should actually say, instead of increasing, decreasing, it should say growth and decay. So question A, the starting is 200. This is an example of growth because the value, the ratio on the inside is greater than 1. So this is going to be growth. And the question is, how much bigger than 1 is it? So I know I can see this 0.035, and I just need to think, if I move the decimal back, what percent is that? And the answer is that this is growth of 3.5%. Question B starts at 1.25. I can tell that this is an example of decay because the ratio in here is less than 1. So how much less than 1 is that? And it looks to me like that is 6% less than 1. That's how far away from 1 I am. All right, and like the others, this 14 is not one of your problems. So I will answer maybe some quick questions for you on Friday, but really make sure that you've done your best to study for this on your own.